Okay, now it's recording. Okay, so here we go. Do you remember something called SOHCAHTOA? Write that down. It's an acronym. It's used to help you figure out trig ratios. Excuse me. And it can only be used for right triangles. Cool or not cool? Okay, the S stands for sine, SIN. The O stands for opposite, OPP. And the H stands for hypotenuse, and I'm going to abbreviate it HYP. The C stands for cosine, COS. The A stands for adjacent, ADJ. And the H again is hypotenuse. The T stands for tangent, but we're going to spell it like tan. The O stands for opposite again, and then the A stands for adjacent. Are we okay so far? So I have a right triangle, guys. They call these points on this triangle vertices, and usually you identify them with capital letters. So vertex A or angle A, the opposite side of angle A there, that's going to be segment A or little a. You can also say like angle B creates little b. I think that's how some textbooks have had it. And then this angle here where this aims, that's going to be little c. And all right triangles, all of them are related by a squared plus b squared equals. And what theorem is that? What is that called? Pythagorean theorem. Are we in the clear? Okay, perfect. So here's how you do it, guys. SIN, I know it's spelled sin. You don't say it sin. You pronounce it sine. Pronounce it with me. Sine. Sine. That's how you pronounce it. So sine A, according to this little abbreviation, you use your SOHCAHTOA, you use your acronym. Sine is opposite over hypotenuse. It's a ratio. So I go to angle A. So I'm going to put angle A in blue here. So here's angle A. Opposite, little a over hypotenuse. A over C. Does everyone see how I got that ratio? No? All I did was wherever angle A is, the opposite side, that's the arrow here. Opposite side is little a, the segment little a, and it's always over the hypotenuse. Opposite over hypotenuse. How do we feel? Okay. Next one. COS, it's pronounced cosine. Say it with me. Cosine. Cosine. So it's cosine of A. Cosine is adjacent over hypotenuse. What does the word adjacent mean? So do you guys have little brothers, little sisters? If you were to give your little brother or little sister this pen and go, take it to the adjacent room, hopefully they would use context clues and figure out that it's the room next door. That's exactly what this means. So what is the segment next door? And I guess you can say the C is a segment next door, but that already has a name. This, you call it the hypotenuse, no matter what. It's the longest side of a triangle. So what's next door to angle A? Segment B. Do you guys see that? So B over C. Adjacent over hypotenuse. Next, tangent. Tangent is opposite over adjacent. So opposite A over adjacent B. How do we feel so far? Nothing crazy, right? All right. Now, these are called the reciprocals. Cosecant, secant, and cotangent. Don't worry, you guys are going to say it with me. Cosecant is the reciprocal of sine. So, CSC, how do I pronounce it? Cosecant. Say it with me, guys. Cosecant. Cosecant of A. So, it's a reciprocal of sine. So, let's just take the reciprocal. C over A. How do we pronounce CSC, guys? Cosecant. Say it again. I can't hear everyone. How do we pronounce it, guys? Cosecant. Okay, thank you. Sorry. I wanted to make sure that we're awake. SEC, you pronounce it secant. So secant of A. Oh, what happened? What happened? Let's say it. Oh, sorry, miss. SEC, you pronounce it secant. Secant's a reciprocal of cosine. So you just go C over B. See? Bless you. Did someone sneeze? Okay, yeah. And then cot. You don't pronounce it cot. It's actually pronounced cotangent. Cotangent. Say it with me. Cotangent. Cotangent's a reciprocal of tangent. Everyone gets this one right. So B over A. How do you feel? ¿Cómo te sientes? Bien. Or am I saying, how do you sit? ¿Cómo te sientes? Okay, I'll stop. All right, here we go. I'm going to do it. If you have colored pencils, this is probably a good location. I'm going to do again the same thing, but with angle B. So here's angle B. I'm doing sine B, opposite over hypotenuse. So it's going to be little b over c. Does everyone see how I got that? Next one, the cosine. Cosine of B is adjacent over hypotenuse. So adjacent A over C. Tangent B. Tangent is opposite over adjacent. So B over A. Cosecant B is the reciprocal of sine. So the reciprocal of sine is C over B. Secant B is the reciprocal of cosine, so I'm going to write C over A. And then finally, cotangent of B is the reciprocal of tangent of B, so I'm going to write A over B. How do we feel, guys? Okay, perfect. And then just real quick, I'm going to just put a really fast example. If I have a right triangle right here, let's do the most basic one that we can think of, 3, 4, 5. And I write alpha there and gamma here, or beta. That's not a gamma, that's a beta. Alpha, beta. Alpha and beta. So if I were to tell you what is cosine of alpha, with respect to alpha, what is adjacent? The 3 or the 4? Yeah, you said it. Which one is it? 4. And then what's hypotenuse? 5. So if I were to tell you cosine of beta, with respect to beta, what is adjacent? 3. And then hypotenuse is 5. So that's just an example. It comes out all the time in the SAT, ACT. All right. Cool. All right, here we go, guys. Hopefully these notes look familiar. I stole them right from the geometry curriculum. So here we go. I have an angle. I have angle A. So I'm going to write my angle like that. And it says sine A. So opposite over hypotenuse. What is opposite to angle A? 5. And the hypotenuse is 13. Perfect. The hypotenuse is always the longest side of a right triangle, guys. Or wherever this aims at, that's always your hypotenuse. HYP. Okay, cosine of A. Cosine of A is 12 over 13. Tangent of A. 5 over 12. There it is. You guys got it. You guys are beasts. I'm going to change my colors to blue. I'm going to go to C. So there's angle C. So sine of C, opposite over hypotenuse. What's that? 12 over 13. Then I'm going to go cosine of C. Cosine is adjacent over hypotenuse. I'm going to write 5 over 13. And then tangent is opposite over adjacent. So I'm going to write 12 over 5. Are we okay? All right. This is what you're going to be doing on delta pretty much today. I have a missing side. I'm going to call that little y. So how do I get little y? Little y is nothing more than the square root of 9 squared plus 12 squared. 144 and 81, that is 225. And I believe that's 15. The square root of that. Are we okay? Okay, so there we go. So here we go. Here is W. I didn't mean to say it like that. It's W. So here's W. So opposite over hypotenuse, 12 over 15. But notice it does reduce, guys. 3 goes into 12 4 times, and 3 goes into 15 5 times. So 4 over 5. If you don't reduce it, that's fine. But you always want to have in reduced form. Cosine W, adjacent over hypotenuse, 9 over 15. 3 goes into 9 3 times. And 3 goes into 15 5 times. So 3 over 5. And then tan W, opposite over adjacent, 12 over 9. 3 goes into 12 4 times. 3 goes into 9 3 times. Are we feeling okay? All right, I'm going to go ahead and use red for x. It says sine x, opposite of our hypotenuse. So 9 over 15. 3 goes into 9 3 times. 3 goes into 15 5 times. Cosine x, adjacent of our hypotenuse. 12 over 15. So 4/5. And then tan x, opposite over adjacent. 9 over 12. So 3/4. Are we getting better? Right, yeah. We're not getting better? Are we getting better? Okay. All right, sorry. No yawns, that's a demerit. Here we go. Remember from your, okay, this you definitely did do in geometry for 100%. 30, 60, 90 has a relationship n square root of 3, 2n. Write that down somewhere. 45, 45, 90. You should really be putting the degree symbol in there. Is n square root of 2. And in case we're wondering, I have no idea what you're doing, Chavez. I just see that you're putting numbers and letters, but you're not connecting anything. Here's what I'm trying to tell you. In a right triangle, they call these legs. This is also called an isosceles right triangle. Isosceles right triangle. And in an isosceles right triangle, they call these legs, and those legs are going to be defined as n, or the behavior of n, or segment length of n. So leg is n. And then the hypotenuse, this guy, is going to have n square root of 2. See? These formulas, guys, these formulas did not just happen. I don't want you to, well, I guess you can memorize them, but I don't want you to become a robot. They come from somewhere. Remember Pythagorean theorem? So check it out. If I were to figure out, let's look for this using Pythagorean theorem. So square root of n squared plus n squared, well, that's the square root of 2n squared. Well, check this out. The square root of n squared is just n square root of 2, OMG. That's the hypotenuse. See? All these are coming from somewhere. They just don't magically just appear, guys. Okay? All right. Here we go. All I'm doing is using my formula for 45, 45, 90. That's all you're doing. n square root of 2. So they're telling me that this leg is 8. So then that means this leg, where the x is at, must also be 8. Do you see how we did it, guys? The hypotenuse must be 8 square root of 2. That is the perfect length. Yes, you can say, okay, if you wanted to, you could have said, well, I want to figure out what y is. Y is the square root of 8 squared plus 8 squared. And then you probably, don't write this down, just listen. Then you would have said, oh, that's 64 plus 64. What's that? 128? Square root of 128, which is the same thing as saying 64 times 2. And OMG, look at that. 64 is 8 times 8. And that's what the definition of square root is. 8 square root. The only thing you have left under the radical is a 2. OMG. Do you guys see that? So there it is. Okay. Here we go. 45, 45, 90 again. Well, how do I know it's 45? Because that's the section I'm at. If this is 25, then y has to be 25. And then the hypotenuse x has to be 25 square root of 2. Do you guys see how we did it? All right, now we have a hypotenuse, this 19. Notice there's not a square root of 2 on that one. So we're going to have to go backwards, right? So here's what you do. N square root of 2 equals 19. Does everyone know where I got that equation from? The behavior of the hypotenuse is n square root of 2. So if you want to get the side length by itself, you just divide by square root of 2. 19 divided by square root of 2. That is the answer, but you want to, it's called rationalize, meaning that I don't want to have a radical in the denominator. So this, I'm going to multiply by square root of 2 over square root of 2, which is just 1. So 19 square root of 2 over 2. That is what x and y is. 19 square root of 2 over 2. 19 square root of 2 over 2. And I know, at least yesterday, that we had some, I wouldn't call them haters, but like some non-believers. They were like, 19 over square root of 2 does not look like it's 19 square root of 2 over 2. Like it is. It might be still here in the memory. Let's see. Because it's the last thing we did. I hope it's still there so I don't have to type it again. Yeah, it's still there. Check it out. 19 divided by square root of 2 is this decimal, 13.435028884. It actually keeps going forever. And check it out. 19 square root of 2 over 2 is that same decimal digit per digit. Cool, right? Okay. Let's keep going. That's probably the hardest part. This is a 30, 60, 90 triangle, guys. I'm going to change colors here so you won't get confused between the red and the blue here. In the 30, 60, 90 triangle, the smallest side is always your reference. So I'm going to call that N. Then the 60 degree is the longest side. So you're going to, not the longest side. Oh, it is. It's a side. The longest side, so that's going to be N square root of 3. And then the 90 is your hypotenuse, so 2N. I should say longest leg, not longest side. Sorry. Are we okay, guys? Okay. So shorter leg. The shorter leg, here's 30 degrees. So this is my shorter leg, N. N. Long leg, the longer leg comes from the 60 degree. So that's going to be N square root of 3. Not 2, but 3. And then the hypotenuse. The hypotenuse is this guy. That's going to be twice the short leg. There's my formula. And now here we go. We're ready to rock and roll. All right, here we go. 60 degrees. They give me the 5, so that means that 5 has to be the short leg. That's your N. So then that means the X has to be the long leg. So that's going to be the N square root of 3. So take the 5 and multiply it by square root of 3. So 5 square root of 3. Leave it alone. And then the Y has to be the hypotenuse. So we're just going to double the Y. Double 5 is 10. Are we okay so far? All right. Next letter. I know it doesn't look like it's a 30, 60, 90, but it is. They tell you that's 30, and I have a 90 there, so that means this angle there must be 60. So the 14 is the short leg. The Y has to be the long leg, so 14 square root of 3. That's the Y. And the X has to be double the 14. So what's that, 28? And there it is. How do you guys feel? Okay. Last but not least, the hypotenuse is 32. So the relationship that I can go from the hypotenuse, I can go directly to the short leg. If the hypotenuse is 32, that means the short leg has to be 16. And then I just take that and multiply it by square root of 3. 16 times square root of 3 is, well, that. 16 square root of 3. All right, before we let you guys loose, there's a little bit that we got to talk to you about. Just a little bit. So, are you guys good with radicals? So, if I tell you square root of 12, can you reduce that? Yes. 3 times 4 equals 12. And the square root of 4 is 2. So 2 square root of 3 is equal to square root of 12, right? All right, next. If I tell you square root of 6 divided by square root of 2, do you know what that is? Laws of exponents. I have a square root, I have a square root. How many times does 2 go into 6? 3 times, so this will be, Mr. Vega, square root of 3. Does that make sense, guys? Okay, so that was the hardest part that you guys had issues with, just the radicals. If you guys understand radicals, then we should be good, guys. So go ahead and take out your tablets, laptops, whatever it is, and see if you guys can knock out today's delta. Log into Canvas and just click on the link. That's probably the fastest way. Nah, it's just delta math. We should have had a test last week, TBH, but